Oh, thank you very much, Josh, for this presentation today. I'm very excited. And whenever you're ready, please introduce yourself and start your presentation.
Sure. Well, thank you so much, Cecilia, for asking me to give a little talk here. I'm very pleased to connect with the tech community. So I'm Josh Malina. I'm from South Florida, currently up in DC, but I work for American Express based out of Sunrise. Cecilia, is this group primarily Floridians?
Yes, yes. We started as Floridians. Right now we are virtual, so we have people from everywhere.
Great, great. Well, yeah, so I work at Amex. I've been there for about 2.5 years. I'm a senior ML engineer and been working on a lot of time series stuff for the past couple of years. But I recently started playing around with some facial and other image recognition technologies as a side project, and it just seemed like a good opportunity to share what I learned. Nothing too groundbreaking, I'm sure, but really quite amazing how far we've come, both in terms of how good AI is for facial recognition and object detection, and also just how easy it is to leverage state-of-the-art ML using, you know, cheaply. I don't know what to say about the prices, not freely, but available APIs from, these big cloud providers. So I'll share my screen and walk you through a notebook. Also, there's a couple of ways of doing this, and I think one way to do it is to kind of just go through the notebook. But if people on the call have collections of photos of people with faces and they were interested in running this notebook themselves, we can also make time for that because I think the presentation itself won't take up the whole slotted time. So yeah, please don't hesitate to just shout out things, hopefully nice things, but it's good for me if it's interactive. And I'll pause also to allow time for comments or questions, but also feel free to interrupt. Okay, so let's see. It's the first time using Microsoft Teams, so we'll try to do some sharing. What can I share? Oh, I can't share an application like in Zoom. I have to share a whole window, huh? You have to see everything. Wow.
You can choose.
I can? It
Yes.
seems my options are uh let me see here. I don't even know what it means to share a window, but
They changed the layout. I think the window are the apps, probably.
okay. Well, hopefully. Do you see my screen or no?
No, I'm seeing your camera.
My camera.
Yeah,
Yeah. I guess I'll just share the screen then. How about now?
it's coming. Yes, now we see your desktop.
Do you see this Chrome browser?
Yeah.
Okay, great. Okay, so I always get really excited about AI when it can be used to solve real problems. This is sort of just a private opinion, but I sort of think that in a lot of organizations, people get really excited about machine learning or artificial intelligence, but it's not necessarily the right tool for the job, nor does it really make sense to use it. But sometimes AI just kind of leaps out at you and says, choose me, I'm the best tool for the job. So that's what happened. I'm an avid cyclist, and a couple of months ago, I participated in a gravel bike race in West Palm Beach. I have my gravel Fort Lauderdale shirt I wore for today's event, and I had a good time. I had a very fun time. You can see me here having a fun time. But what was surprising to me was after the race was over, I got a link to the photos, and it was like 1,000 photos of people who look just like me, and I was supposed to weed through them and use my own facial recognition ability to find my pictures in case I want to buy them or send to my mom or something like that. And I was like, whoa, aren't we in 2021? Like, doesn't this photographer guy, isn't he up on the latest machine learning? Like, we can solve this problem faster. So I emailed him and I said, "Hey, Gabrielle, love the pictures you took, but there's got to be a better way of sorting these photos. I'm thinking of doing a little pilot with Amazon. If it works out, would you be interested in kind of participating in this journey with me?" And he was very excited because he gets the same complaint from a lot of people. They'll have a triathlon, they'll have 3,000 participants, 10,000 photos, and it'll just take a while to find your photo. And then people just give up and they won't buy it. So this seemed really exciting and possibly even a business opportunity. So I decided to take some of my spare time and investigate it. So I'll just pause there for a second in case there's any comments or questions. Okay, so the one big doubt that I had in my mind about whether this would work was, is ML for facial recognition good enough that they could take one photo of me that I tell them is Josh and then find other photos of Josh? Because the cold start problem, if you have just a single instance of something that you're trying to classify or predict, maybe you don't have enough data. Fortunately, and spoiler alert, it did quite well. And I think that's because my face is not so different from the millions of faces that I'm sure Amazon has trained this algorithm on. And so it already has a very good machine learning model for distinguishing people's faces. But you'll see it's not perfect. So if you want to get started with a project like this, there's a few things you need to know. One is not necessarily Python, actually. So when you work with Amazon's web services, you can choose. You can use Bash. You can use Java. You can use Python. I think you can maybe even use JavaScript. I wonder, is there any way for me to interact with you guys? Is there like a hand raise? I'm curious how many people have used AWS in the past. I think
Yeah,
there's a hand.
we have a functionality there with hands. People can raise a hand, like, heart,
Oh, good.
applause.
Okay, I see Lanice has and Scott and Raymond. Whoa, the hands are just they're coming towards us. Okay, so we have a handful of people who know what Amazon Web Services is, or maybe everyone does. Like the other Microsoft Azure or Google Cloud, it's a suite of opportunities, suite of services for deploying code into the cloud, and about 1,000 other things. I think one complaint that AWS used to get was that it was so difficult just managing it that people didn't know what they were doing. I think the way it looks these days is probably a little better. Yeah, it used to be the case that it was just this one page with like a million different pictures of all the things that exist, but it seems like they have improved the user experience a little bit. So with AWS, you get this 1 year free. Probably not for all their services, but you get a lot that you can try out. And full disclosure here, I just kind of make a new email address whenever the other one expires, which is probably illegal or violates some terms of service. But yeah, not sure why I even admitted that, but I did. So Amazon's suite of APIs that you can use for machine learning is called Rekognition with a K for some reason, and you can do a lot of different stuff. If you just look over here on the side, you can do object and scene detection, facial analysis. They even have an API just for recognizing celebrities. So if you're famous enough, maybe you are somewhere in their training data. Text and image. There's a lot that you can do with Amazon Recognition. I don't know that much about pricing because I'm still in the free tier, but it's pretty good. So I would check it out. So you need to get signed up with AWS. Also, you need to configure your computer to be able to use AWS. So there's some keys. I have this getting started guide here, which I think is also open over here, that helps you sort of get up to date. figuring out which packages to use for those Pythonistas out there. Boto is the SDK, is the way that you interact if you want to use Python to interact with AWS. As I said before, you can just do this on the command line, PHP, Ruby, Java. There's many different ways to access these tools. So I'll just take a breath there in case anyone has anything to say. Okay, 2 breaths. So the first thing you're going to need is some data. Now, I have a bunch of photos that look like this that I was able to work with, but any collection of photos that you have of, human beings with faces, specifically, you want to have at least a few people appearing in multiple photos. Otherwise, there won't be any comparisons that you can do. So I scraped these from the photographer's website. That's why it still has the watermark on it. And so my question was, can I take this one photo and bring back, the dozen or maybe half dozen photos that exist in the data set? So here's me installing Boto 3. So the first thing that you need to do is put your photos up in S3. And S3 is Amazon's main way of storing documents. So let's see if we can find a home page here for S3. It's very popular. A lot of people use it. A lot of companies use it, personal projects and really big commercial projects. So when you go into S3, the first thing you need to do is create a bucket. And a bucket it's kind of synonymous with a folder, although I'm sure there are some important differences. One interesting thing about Amazon that can sometimes be pretty complicated is there's so many different settings. It's a little easier to use now than it was maybe 5 years ago, but whenever you create anything, you are asked to set permissions and create roles and groups. And these are all important, good things for security and restricting access, but there is a bit of a learning curve. So in this case, none of my photos required any sort of privacy or encryption, so I didn't sign up for any of that, but you'll see that when you create a bucket, they will ask you a lot of questions. So buyer beware. So I created this bucket called Gravel Photos 2, and I uploaded a lot of files. Yeah, it's pretty simple to do that. So I've got all my photos in here. So now it's in the Amazon ecosystem. Now that it's in the Amazon ecosystem, it's easier to use Amazon Recognition, the machine learning API, to iterate over those images and do the things that we want with them. So let's go back to our notebook here. The first thing we're going to do is create what Amazon calls a collection. And there's a really good description of what a collection is. I had it up here, I think. Let's see. What is a collection in Amazon Recognition? Oh, here's the definition. They're server-side containers. So they don't sit obviously on your computer, they sit up in Amazon. And what you can do with these collections is you can build indices or indexes of people's faces, which is what we're about to do. So you create a collection, you give it a name. Amazon's API is also sort of known for these keyword arguments that you kind of just need to know or just look up in the documentation. But here it's only required that we have a single argument, which is nice. We're calling it gravel faces. And this is stuff I did later, but here you'll see what the main call is, which is index faces. So what this is going to do is it's going to take every photo in my bucket, this bucket, Gravel Photos 2, and it's going to index it, which is to say it's going to capture information about, how far my eyes are from each other and my nose and, my hair color and all that. It's probably not explicit. It's probably some, semantic representation, some giant array or matrix that Amazon has figured out represents significant features in photos. But it's going to create sort of like a fingerprint or a signature for each of the faces in each of the photos, including photos that have multiple faces in it. There are thresholds you can set where if a face is like too small, or you only want to index or find the top 3 faces in terms of size, you can do that. But I think for the most part, it's going to try to find all the faces in there. So this is the first thing you need to do, which is index faces. So I'll just pause here again and see if there's any comments or questions. Okay, great. So you can see here I've done that. This takes a bit of time. I'm not actually sure if there's a batch call where you can say submit the entire buckets photos. Here you see we're just doing a photo at a time. So, if you had a lot of photos, this could take quite a bit of time. You're making an API call, for each photo. But, minutes, not hours. So that's fine. And then we want to see, okay, here's this photo of me, this, handsome guy here. He's got a helmet on and a weird little bicycle hat, sunglasses, and the bicycle, of course. Can we find more photos of this guy so that I can pay this photographer and send these pictures to my mother? That's really the name of the game here. So let's see how we did. Let's go down here a little bit. So results. Okay, so I'm calling the Amazon Recognition API again, this time a different endpoint, and that endpoint is called Search Faces by Image. So now you take a new photo or a photo that you've indexed and you match it against all the photos in the index to see if any come back as matches. What's interesting about this call is you don't have to have the photo in S3 already. You can, but you can also just send it up as bytes. In this case, I have the photo up already in S3, so I just sent it that way. So what does our JSON look like? What does the return type look like? What kind of information do we get? So one thing we get is where the result is. Where is the face that it thinks looks like me? Well, here it is. Here are the bounding boxes associated with it. Oh, here's the first one right here. So searched face bounding box. So depending on your API, I was using another Python library for doing some object detection. You might get back like xmin, ymin, xmax, ymax, and that'll help you create a rectangle. In this case, Amazon is returning to us width, height, left, and top. Their documentation is pretty good, and you can use that to figure out how to draw boxes around what you found. But you will have to do a little bit of digging through the documentation for that. What else do we have here? We have confidence. So they are very certain that the first photo returned is me. So we'll look at that in a second. And then there's a couple of other parameters returned. Image ID, external image ID, which is nice because this is actually the name that we know it by in S3. So let's take a look because it looks like they found a lot. So again, I think this is the photo I searched with. Yep, and let's see what it got. Well, okay, 99.97% they think this young man with his tongue out is the same guy. And I know from years of looking at pictures of myself that this is in fact me. So, bravo. With just a single photo, Amazon was able to find this, and its first return result was correct. So, for some of you that might not seem sort of like breathtaking or like interesting, but I think just giving it a single photo and having it return its first result back, I think that's pretty compelling. I mean, it's the same guy, obviously, but there's, some differences. There's a tongue in this one that there wasn't in this one. And the other thing that's worth mentioning, and I haven't showed you the other photos, is everyone in this race looks like one of these two people. It's mostly guys. A lot of them have beards. Most of them have sunglasses. They're all wearing helmets. So it's not like you're comparing photos of people in, different clothing doing different things. There's a lot that's very similar. So here we see the first result was a match. Second result, this is, I think, a slightly different photo. You can see that's also a match. Third photo, we're still doing good. Oh, okay. 97%. I wonder what it found. Might have been the white helmet or the beard, but I know from years of looking at myself that this is not, in fact, me. So it got it wrong. It's not perfect. Well, okay, here it got it correct, and here it got it wrong. Same guy. So let me just pause there again and see if anyone has any comments. Are you guys surprised, I guess, that it did this well or this poorly? Do you think that the API is performing well? What is your opinion?
James?
Yeah, it kind of depends on the range of confidence scores, doesn't it? I mean, like, are they all just ranging from like 85 and above? And then second, I mean, I was pretty surprised. I was wondering if there were other ways to include. I mean, obviously, like what you're wearing is an obvious indication that that's not you. So, is there any way to include that? But this is just facial recognition right now, so.
Yeah, that's a good point. Maybe that's why I got it wrong. It's just looking at the face and not the clothes.
Yeah, I was going to suggest if there was a way to identify bikes, to add that kind of feature.
Yeah, it seems almost strange that, I guess it makes sense that it's called it's the facial recognition API, but it's such a simple mistake, right? Like, any human knows this is not me. Yeah, I guess we would have to train an algorithm to consider the whole person, and then we probably wouldn't make this mistake.
Yeah, I'm sure you can get really fancy with it.
Oh, and to your point about range of scores, so I'm not entirely sure how low they go. I know it goes from 0 to 100, but you can set thresholds for how high of confidence you need. So they give the example, if you were using this, to admit people into a secure facility, you could set the threshold very, very high, so you don't, have a false positive and admit some, member of ISIS into your birthday party. So you can play with that. Yeah, what else?
I'm wondering how this would work if you use a photo of you without glasses and helmet, right? If it takes in consideration like this area.
Yeah, that's a great idea. Maybe we should do that. Yeah, let's go. Yeah, let's go through the notebook, and then I think that will be fun to actually try to implement. I'll show you a few other results. So there were also these Venezuelan women. There were 3 of them. They were all wearing the same clothes, and I wanted to try with them. So this 100%, this is the same photo, so we can ignore the first one, but you can see the second one, and this is actually a hard problem even for a human, because they have the same bike and clothes. But if you'll notice, she has like some kind of orange thing on her head that only one of them does. So that's her in the back there. Okay, so that's nice. And maybe this is actually the facial part doing a good job, just focusing on faces, because the rest of their bodies and bikes look pretty similar. She might be here, I'm not sure, but it was very confident about this. So yeah, maybe it is her right here. These are pretty high resolution photos, so I think that also helps. We have her here again. So far I think we're 3 for 3 or at 100% precision or recall. Here's Here's two of them enjoying. I think one of them won the women's thing, so they were pretty happy. And you know what? I don't think this is her. Yeah, 845. Oh, we can tell by the bib number. She is bib number. What is she? What is this? I don't think this is her. I think she's 758. Yeah. So this is wrong right here. But I mean, hey, they look almost exactly alike.
I can't tell the difference.
Yeah.
Yeah, me neither.
Oh, and there's all three of them. So really, really good there. But let me show you another example. This didn't work the way I wanted to. I had it. Oh, yeah. So this guy in the front, he won. He won like the men's. And actually the original image I was using was him without a helmet. And I wanted to show you that. I don't have it right here. But it's kind of what you were getting at. Let's give it a whirl. Let's try putting a photo of just me without a helmet on and seeing what we can get back. So let's see if I can use photo booth at the same time. Okay, great. Let's just take a screenshot of this. Can you guys see all the things I'm doing?
Yes.
Yep.
Yeah, so yes, that's a good thing. So let's give it a whirl. Let's upload this file of this screenshot. Let's give it a. We can rename it afterwards, I think. Okay. Where is she? Let's refresh this page. There she is. Okay. Kind of want to rename this. Actions. Rename. Okay. No bike, no helmet. Okay, let's remember this name, no bike, no helmet.png, and let's ask the machine what it thinks. So I have a function called get results. It should be as easy as this. Whoa, look at that. It only gave us 2, but that's me, you know.
But
So
it worked.
it worked good.
Wow.
Yeah, that's really weird actually, because I have like sunglasses on. It almost
Pretty impressive.
Yeah, I almost wonder if there's something wrong here. Like, how could it possibly do that? Yeah, it's almost scary. But yeah, makes for a great demo. So thanks for the suggestion.
That's amazing.
Yeah. Any other ideas you guys want to try? I think that's most of what I wanted to show. If you guys want to walk through this with your own photos, be happy to try to do that as well.
Yeah, back on my earlier theme there on the bike, is it supported to do different types of objects other than faces?
I don't think so. I don't think it is. But to that end, I have, for another use case, I've been using this Python library called Detecto that is very simple for training models to do custom object detection. So you could do this for trying to classify bikes. So what I've been using it for is because the photographer I'm working with, he wanted to take it a step further and do automatic bib recognition and translation. So like this guy's 799. So I trained a model. It took a while creating the training data, but it did really well out of the box. So I don't think Amazon itself supplies that. Like I guess what I'm trying to say is I don't think Amazon is going to say like, hey, we have great models. Give us some more training data. We'll create a custom classifier for you. I don't think they're doing that. I think they're going to let you use their already pre-trained models. So if you're looking for, cars or humans or whatever, or couches or something, they're going to do that. But if you want to train what is this? Custom labels. Well, I spoke too soon, I think. Build your own custom machine learning model to find objects and scenes unique to your business. So there you go.
Cool. What was that called again? I'm sorry, just custom labels? Yeah, okay.
Yeah, I'll put this URL in the chat. Oh, we have some things in the chat. I wasn't even here. Interesting. That's pretty amazing. Awesome. Yeah, I agree. Yeah, it's quite good. It's a little scary. This technology is obviously for neutral purposes like this, or I think famously the Chinese government is using things like this to persecute Uyghurs in Western China. So AI, man, it's a double-edged sword. So
What was the name of the library, the Python library, the defecto, the texto? What?
yeah, let me put the link in the chat. This is a good. I trained this a model using this to find both bibs, and sometimes in races they write their numbers on their arm in Sharpie. That's much harder, but I did a skin number detector also, and it did okay, but not nearly as good as the bibs, which was actually very good. So is there any questions? Anything else you guys want to chat about?
So were you able to make a business case for this photographer?
Yeah, it's funny you should say that. I've kind of been in the weeds with this for a month or two. I thought it was a really good idea, and I thought, like, this is a really good business opportunity, but I've talked with people that have spent years trying to make a dollar on this exact problem, and it turns out that the margins have to be so low for it to make sense for the photographer. Like, the photographer sells like very few of the photos. So unless you're charging the photographer like more than like, or less than like 6 or 7 cents per photo, it's not going to be in their interest to use the service. And when you need to host the photos and the compute power to run the models, I don't know, it winds up not being super profitable.
That leads to another good question is roughly how much does it cost for that S3 storage and the compute power just for a project like this? I mean, are you talking about $1 or $10 just for the one project?
Yeah, it's a good question. What does S3 cost? Okay, so if you have 50 terabytes, it's going to cost you two cents and a 3 after that per gigabyte. I don't know what how that.
S3 is super cheap. I wonder about the API.
Okay, for the recognition, let's see, AWS recognition price. Okay, so $1 to do this on 1,000 images. So this isn't a penny. This is what, like a fraction or a tenth of a penny. Yeah. So, I mean, but you need to do more than that. What I found is you first need to train a model for finding the bib, and then you need to send it to another API for detecting the text. And you need to have them upload like their 10,000 images up into your cloud service. I was excited as maybe you guys are. I'm somewhat less excited now because I've talked with people who weren't able to make it worthwhile, but perhaps there's a good way to do it.
This is super fun.
Thanks.
Yeah, of course. And I'll share this share the notebook with you guys if I have an email address I can forward it to whomever.
Yes, please. I can upload this to the share folder, SharePoint. So you were trying this on your computer, right? Connecting to the API and everything.
Yeah, the API calls are just local. Actually, when I was using that Detecto library to train a model for finding the bibs, I couldn't do it on my MacBook Air because I need a GPU. So I used Google Colab, which I wound up paying like $10 a month for, so that they don't turn it off every 5 seconds. So yeah, some of this stuff requires more serious hardware, but there's a lot of environments available that are pretty inexpensive to, if you really do need to train, a big model.
Nice.
Yeah,
Now,
has anyone else on the call done any image stuff? I'm curious.
like, James?
Well, this is not related to like the facial stuff. So I was thinking about like the Detecto thing, and I work in a research lab, and we do all kinds of like microscope images. And one of the things we do is we look at these microscope images, make little circles in the image of what we want to count, and then basically repeat that manually. And so just automating that away would be a big time saver. And so you said that with Detecto, you can kind of create your own images and then it'll train models to recognize that. Is that correct?
Yeah, so with Detecto, they recommend this other piece of software that allows you to draw the bounding boxes, which wind up being the ground truth for the images to be able to train. I don't know if I can forget what it's called. I can show you in the documentation. So where's the getting started? Quick start.
I'm also so curious what's happening under the hood.
So for Detecto, I know it's just a wrapper around PyTorch models. And I think the PyTorch models are downloading pre-trained weights that I don't know exactly the weights that were trained, but probably something amazing that was trained on like 1 billion images. Yeah, where is that? Oh, here it is. Yeah, so there's this project called Label Image, and it's a little GUI that you download, and you kind of draw the boxes and you give it labels, and then it gives you an XML file for each image that has the bounding boxes in it, and that's what Detecto likes as input for building a custom object detection model.
Have you used this before? Like, how many boxes do I need to provide to get it to be, I don't know, at least like 80%?
Yeah, it's definitely a question that I have a simple answer, but I think there's a recommendation about somewhere in here. I did it, and with bibs, I did it, honestly, it was kind of fun, doing like grunt work like that sometimes. I think I did it for maybe about 100 images, and it's amazing for detecting bibs. I don't know what kind of little gross things you guys are looking at in your microscopes, but it might be similarly successful.
Huh.
Yeah, take a look.
Yeah, cool stuff.
Yeah.
Getting into the future already. I don't even know what's happening under the hood, but now we can just do this so easily. Crazy.
Yeah, who cares what's happening under the hood? Leave that to the mathematicians.
Yeah, I only ask. I only joke about like figuring out what's under the hood, just because at least in like the biomedical field, people are starting to use AI for all these different applications, but it's kind of like, especially with really high risk scenarios, like when you're actually treating patients or something, like how do you know what kind of inputs you can use in those models to get a reliable output? Like, can I just throw in any kind of patient data in this model and it'll give me an accurate output, and so on? So it's kind of like a active discussion right now. How much
I know
about the underlying models or anything or something like that?
for learning a lot about neural networks somewhat quickly, I took a few of the fast AI courses. I don't know if you guys have come across those, but the YouTube videos, the training material is very hands-on and very easily digestible and very free.
Yeah.
So that's a cool place to learn.
Making neural nets uncool again.
Yeah. So they have this course called Practical Deep Learning for coders, and it's good. It's very good. I've recommended if people want to learn both the theory and the practice kind of simultaneously.
Gotcha. Cool stuff. Thank you.
Yeah. There we go.
Awesome. So I will stop the recording. Thank you very much for these presentations.